Welcome to this explainer on NCP-MCI 7.5, specifically focusing on Acropolis Dynamic Scheduling, or ADS. Look, if you're an infrastructure admin managing Nutanix environments and you're studying for your Nutanix Certified Professional Multi-Cloud Infrastructure exam, getting a handle on how ADS manages workloads under the hood is absolutely essential. It isn't just about passing the test, right? It's about keeping your clusters running smoothly in the real world. To get you ready, we're going to break this down into 4 parts. Why ADS matters, exactly how it works, the exam traps and edge cases you need to watch out for, and finally, the key facts you absolutely have to memorize.
Okay, part 1, why ADS matters. Let's start with the foundation. What exactly is this feature, and why is it so critical to your cluster's health?
Think of ADS as the intelligent traffic controller for the Acropolis hypervisor, or AHV. Out of the box, it's enabled by default, and honestly, Nutanix strongly recommends leaving it exactly that way. Its main job is to proactively monitor your cluster over time, keeping an eye out for compute and storage contentions, what we call hotspots in the data center. When it spots a problem, ADS automatically steps in. It creates a runtime optimization plan, which usually means migrating virtual machines or VMs from one host to another just to balance the load. The beauty of this is that it ensures all your workloads get the best possible access to resources without you lifting a finger. So, no more waking up at 2 a.m. to manually balance a bottlenecked cluster. Moving right along to part 2, how ADS works. We're going to do a detailed walkthrough here. Let's see how this actually operates mechanically by looking at a couple of concrete scenarios. Grasping this sequence of events is super important for those scenario-based questions you'll see on the exam. At a high level, ADS runs in this continuous 3-step loop to detect issues and dynamically defragment the cluster. First up, it systematically gathers statistics from the specific components it's monitoring. Second, it checks those stats against built-in thresholds to spot potential anomalies or resource constraints. And third, if it decides a host is undeniably overloaded, and crucially, that a fix is mathematically possible, it invokes the necessary tasks. Usually that means triggering live VM migrations to clear up the bottleneck. But the real magic, it's all in the timing of these steps. Let's look at our first example, mitigating a CPU hotspot. Imagine a scenario where host CPU utilization just suddenly spikes because of a massive morning boot storm. It's a classic admin headache, right? A massive wave of users log into their virtual desktops right at 9 a.m. and CPU usage on a specific host goes completely through the roof. So the question is, does ADS panic and immediately start migrating VMs to save the host?
Well, no, it doesn't. And what's really interesting here is the threshold it uses. ADS will only trigger a migration if the average host CPU or storage CPU usage stays above 85% over a 10-minute period. Behind the scenes, it's actually running its underlying check every 15 minutes to look for that specific, sustained 85% average.
Because it strictly relies on that 10-minute average, ADS intelligently ignores those short-lived boot storms. This prevents a bunch of unnecessary and chaotic VM shuffling across your entire cluster. By using trend analysis instead of just a simple point-in-time check, ADS essentially understands that transient spikes are just a normal part of enterprise life. It only reacts to sustained, legitimate resource contention that genuinely threatens your workload performance. Okay, let's transition to our second concrete example, mitigating a memory hotspot. This one behaves quite differently from CPU monitoring, and honestly, this subtle difference is super easy to mix up on test day. The contrast here is pretty stark. ADS checks for disk swapping every 2 minutes, but, and this is a big but, it only does this if you have memory overcommit enabled on the cluster. If overcommit is disabled, ADS doesn't monitor memory at all, because the memory is statically assigned. When it is enabled, that rapid 2-minute check lets ADS quickly catch VMs that are being forced to swap memory pages to disk, which we all know is a massive performance killer. Once it detects that swapping, ADS generates a migration plan on its standard 15-minute interval. It redistributes those VMs and allocates the physical memory they need so the swapping finally stops.
Now, once ADS actually executes a migration plan to fix any of these hotspots, it initiates a strict 11-minute pace period.
Think of this 11-minute pace period as a mandatory cooldown timer. It's a hard pause to let the cluster completely settle down. The whole point is to make sure that the next time ADS runs its checks, it's evaluating fresh, accurate statistics instead of just migrating VMs endlessly in a loop. Basically, ADS makes a targeted change, takes a step back, and waits exactly 11 minutes to observe the real-world impact before it even thinks about drawing up any new plans. All right, part 3, exam traps and edge cases. Pay very close attention here, because certification exams absolutely love testing the exceptions. They want to see if you know the strict rules and boundaries where ADS actively refuses to intervene. Knowing these will bulletproof you against trick questions.
First up, if a VM is configured with certain hardware-bound features, ADS will absolutely bypass it when creating a remediation plan. Specifically, if a VM is using Windows Defender Credential Guard, Virtual Non-Uniform Memory Access, or vNUMA, GPU pass-through, or CPU pass-through, ADS leaves it exactly where it is. It simply will not migrate them. Why? Because those specific features physically tie the virtual machine directly to the underlying hardware limits of that specific host node.
Next, the distinction between initial placement and automated mitigation is highly testable. When you first deploy a VM, getting it powered on is the absolute top priority. Because of that, VM-to-VM anti-affinity rules are only soft enforced on a best effort basis during initial placement. But, and this is key, when ADS acts on its own to resolve a hotspot, it will never break an anti-affinity rule. If moving a VM to solve a bottleneck would violate the policy, ADS just rejects the migration entirely. Hard enforcement. Here's another edge case, vGPU compatibility. If ADS needs to migrate a virtual graphics processing unit or vGPU-enabled VM, it has to find a destination host with a compatible or completely identical GPU card. If it can't, the move simply won't happen. ADS is smart enough to know that a virtual GPU workload requires highly specific hardware. Oh, and it will also refuse to move a vGPU-enabled VM if you've manually set a host affinity rule restricting that specific machine.
Also, ADS is fully aware of your high availability, or HA, settings. AHV uses segment-based reservations, basically dividing the cluster into segments based on the largest VM it mathematically guarantees to restart. When ADS is calculating node scores and the cost of migrating VMs around, it explicitly honors those HA restrictions. It will never move VMs in a way that leaves a cluster segment without enough reserved space to instantly power on your largest guaranteed workloads in the event a host abruptly fails.
Finally, whatever you do, do not fall for these trick questions on the exam. There are two major ADS blind spots. First, ADS does not monitor network usage at all. If a scenario asks how ADS responds to a massive network bottleneck, the correct answer is that it does absolutely nothing. Second, it completely ignores nodes that are currently in maintenance mode. If a host is being upgraded or is explicitly placed in maintenance mode, ADS removes it entirely from its calculations. It won't use it for hotspot detection, and it certainly won't use it as a destination for migrating VMs, since those workloads are probably already being drained anyway.
And that brings us to part 4, key facts to memorize. Let's wrap this explainer up with a rapid-fire review of the most critical data points to lock into your memory. Consider this your ultimate cheat sheet for the ADS portion of the exam. Knowing these percentages, intervals, and the specific command line interface or CLI command is going to give you a massive advantage. Let's review one last time. CPU and storage hotspots? Checked every 15 minutes, and they require greater than 85% utilization over a 10-minute average to trigger an action. Memory? It's only monitored if overcommit is enabled, and it checks for swapping every 2 minutes. After any migration plan happens, there's an 11-minute pace period where the system settles down. And lastly, while Nutanix definitely recommends keeping ADS on, if you ever need to disable it from the controller VM command line, the exact syntax you need is acli ads.update enable equals false.
With a firm grasp of the why, the how, and the edge cases of Acropolis dynamic scheduling, you really do have everything you need to conquer this topic. Think about how this automated intelligence fundamentally changes the day-to-day life of an infrastructure admin. It completely frees you from the tedious drudgery of manual load balancing. But, it leaves us with an interesting question for the future. As clusters become more intertwined with AI, how long will it be before ADS evolves from simply reacting to 10-minute averages to proactively predicting and migrating hotspots before they even occur?